Okay, another day, another dollar. So it's running on 100 milliamps, 4 UF run cap, same old transformer in series with number 3 line. I have now no alligator clips except for the meter. And I don't have the alternator hooked up because I wanted to kind of see what's going on with this series transformer. So I'm charging this in parallel with this and this in parallel with that. It's running off the stat power inverter, and the power supply for this is these 2 batteries and the super cap in parallel. And of course there's a full wave bridge coming off of the secondary, 3.5 ohm. The primary is a 9.9 ohm and it's vectored, V-E-C-T-O-R-E-D. Also you can call it a series transformer because this side is in series. Okay, I've talked about that a lot. Now what's very interesting, quite interesting, I started out with 11.85 when you look at the volts across, the 2 caps and the 2 batteries in the super cap. And then it dipped down to, started dropping pretty fast. It went down to 11.79, and then it bounced back up to 11.85, then it went back down to 11.79, and then it started taking off. What is the voltage in the super caps and the 2 batteries, which is running the inverter? And it's taking off. And this is just the series, the run cap coming out into a series transformer rectified into that. And this is also running this. So look at this, it just keeps going up. Isn't that odd? Now, I took what the voltage is and everything before I started, and it was 10.81 for the super cap. This is what was in there in voltage. 10 volts, 10.81 volts, almost 11 volts there. This battery had 12.15 volts. And this battery over here had 11.58 volts. So this was the highest. This is in the middle, and this was the lowest. And I've let it equalize. And look what's happening. Wow. It just wants to go up. So this is surprising. It's drawing 100 milliamps and 120 volts from here. So this is confirming what Hector would say. The run cap phase is over unity in itself. Take it out with a series transformer. Vector it out with a transformer. And run it back into the batteries or the super caps, running the whole show, running the inverter. And it's going to be in cycles. Calls it a hyperwave. So that's what's happening now. God, I wasn't expecting this. I thought the whole magic was in my alternator. So I don't have any jumper cables now hooked up, so I got good connections. So I'll bet you it'll go up to about, say, 14, and then it's going to drop down. But you know, the most we can do is 16, and the super cap will blow up after 16. So let's let that run. Go over here and look at the alternator. So I have super tight. You can see these are plastic rotors, thin, made of, I believe it's acrylic. And then I gooped on a ton of epoxy, make it stronger. But you know that epoxy's not so rigid. So obviously a stainless steel rotor. You can see they aren't exactly flat. And again, the way this makes AC current is there's a magnet here facing north. There's no magnet here, but there's a magnet here and here facing north. So one end of the coil gets hit, and then the other end of the coil gets hit, and then the other end, and the other end. So that's how that's made. Now I think there's something going on. I'm making a drawing about this where the core is re-gauged. The way when a magnet goes past a coil and a core, first, let's say it's going this way. Let's say it's going that way. This would be the leading edge. This would be the trailing edge. That's where the power is in magnets, is over on the edges. And so when it comes by the coil, let's say up here, here's the coil. You see it there? It doesn't matter. When it comes by, and if this is facing north this way, that means it's going to energize the core. Let's just talk about the core for now. The core is going to be energized and want to stick. And so it's going to be south-facing core against a north when the magnet goes by. When it's starting to approach, then boom, the core is now south, facing this way. But when the trailing edge, because it's the movement of the magnet that makes everything happen, when the trailing edge comes up, and that's there, now actually the core has flipped polarity. When it comes up south facing to the left, comes up here, now it's going to be north facing to the left. And you'd say, huh, that's not right, because the face of the magnet here is all south. It's a round kind of hockey puck shaped magnet, and the face of the magnet over here is north, and it's round. So you'd say the whole face is that, but it's not like that, because you know, if you had a motor coil pulsing here, it was like right here, and you had it attract, it'll go this way. The magnet will go this way. But if you have a motor coil over here next to the trailing edge, and you also had an attractive pulse into it, it'll pull it this way. So it'll go nowhere. It'll want to go this way and this way. And so, and think of it as a rectangular magnet. Then you know it's like north over here and south over here. So that's the way it works. If you look on a scope and you line up what happens when a magnet goes by, it goes it goes, sine wave is going vroom, and then it's falling down, vroom. So, what will happen is the core becomes, let's go through that again. Here it comes. This is a magnet north facing this way. Comes up to the coil. Makes the coil go south to the left. Trailing edge comes up, makes it go north to the left, which means the back end will be south if this end is north facing to the left. The back end of the core, let's not talk about just the core, let's just talk about the cores. This will be south when this magnet leaves the coil position, you know. So south facing to the left, north facing to the left. If it's north, that means the opposite end is south. Now, this is called re-gauging the magnet, core. Okay, now look at this. So I have magnets facing north this way, magnets facing north this way, so it's going to make AC, right? Because it'll hit it this way and then this way. So, again, let me just go back a couple sentences. Here goes the leading edge. Makes the, if the magnet's north to the right, the magnet north to the right, it makes the core south to the left. When the trailing edge comes up, it makes the core north to the left, which makes the other end of the core south. Now here's what's cool. This magnet is facing inwards north. This core has just become south. And so there's a free power pole. It's going to naturally go right up to it. If this was north, there'd be a clash. It's like, the magnet has to push its way through. But it has just been re-gauged to be, re-gauged means changing the polarity of, I guess. And so now that'll be south, that core sticking out there. This will be north facing in. You get a free power pole. Whew. And then you get the generator thing going on with the magnet passing by. So, that is my theory why this thing works really well as far as when you load it. And why it spins so well is because it's thin magnets, it's lightweight, and the rotational latch, you'd call it. So what I'm talking about, that would apply to with no load on this alternator too. See how easy it spins? Just whew. And there'll be a certain frequency where it's most efficient, where it gets that free power stroke going on. Look how easy it spins. Okay, so that's this. Let's go back and see where the voltage is. Oh my God, 14.12 volts. So, I don't know. Ah, good. Now it's going down. See? Just up. Now it's going up. This is the hyperwave Hector talks about. You're seeing it in action. Warren Keeler, he did a rotovertor, and he did a series cap, and series transformer, and he had a couple caps, and then he added another transformer, and he had a load of a 12-volt DC boat motor, and he got 1.618 more than what was powering it. And it was pretty definitive test. It was DC, and he also had a stat power inverter. That's where I found out about stat power inverters, from Warren. And these have half the draw of a normal inverter. There's no windings in them, no step-up windings. It has a boost, DC boost converter, like two of them that shoot DC this way and then DC this way. And it makes AC, but it's actually alternating DC. But anyways, these are super efficient. They're great. And so Warren got 1.618 just from the run cap phase. So I think that's what I'm doing now too. I'm getting like more output than input, and I'm putting it into something that's actually running the motor. I'm looping it. I don't have an external DC power supply. So I don't know. I think I'm gonna call it good here, because this is quite interesting how it's gone up so much. And I'm kind of going day by day, trying not to screw everything up, either mentally or physically by things breaking, blowing up. Mentally, just saying, it's worthless, and I give up. So it's going pretty good though. Look at that. So I'm going to call it good here. Thanks for watching.